The other day we made a ball tool the size of the head on a 3/8 rivet. Today I thought we would go ahead and make the riveting tool. I think we'll start with the top riveting tool. And for this I'm using more of the sucker rod. Again, sucker rod is the connecting rod from an above ground pump like an oil well pump to the actual pump in the ground. This piece of sucker rod is considerably bigger than we used the other day. I want plenty of room to create the depression I need for the rivet header, and if I start with something too small, I'd have to upset it, and that doesn't end up being as nice a riveting tool for me anyways. So we're starting off with a piece of sucker rod that is 1 inch in diameter, so that's about 25 millimeter diameter, and it's about 7 inches long, or about 180 millimeters long. Exact sizes don't matter, just make sure it's plenty big enough for your rivet head and it'll be a little easier. I've gone ahead and put this in the lathe and just put a little tiny starting point dead center. If you don't have a lathe, do the best you can with a center punch and create a nice center punch mark that you'll be able to find again hot. But this way I guarantee that I'm perfectly centered. For that matter, if you have the tools for a lathe, you can probably do the whole thing as a machinist's project. If you have the right ball-end mills or special cutters that will cut the perfect shape for a rivet head in this by using a lathe or a mill or whatever it is you've got, that might be one way to go. But most blacksmiths don't have that stuff available, so we're going to do most of this at the forge. Again, that just guarantees me a good center, eyeball center, lay it out with a square, however you need to get a good center mark. Put a good deep center punch mark in there so we can find that mark again with the end of the ball tool. So let's head over to the forge and let's get this piece of steel hot and let's make a rivet setter. Now just to be a little bit different, I thought I would use this axe clamping jig that usually used for splitting the edges of an axe so that I can work right over my anvil, which is better support than working in the vise. You just want to drive the ball punch straight down in here and create a depression. Well, plenty of support, but not necessarily the tightest clamp. So that'll take a few heats to get in there. We may go to the vise and see if that works better, since this is clearly not working as well as I would like, but it is working. This may hold it just a little bit better. If you're a little off center, steer it back to where you want to be. It's certainly working. We're getting a nice depression, but it's still a long way from what we want for our rivet. That's an advantage of doing some machine work first and either pre-drilling or using a mill or something like that. But it can be done entirely with this ball tool. I'm assuming my ball punch is not perfectly symmetrical, and that's why this is a little bit off center, in spite of laying it out in the lathe. But the rivet heads won't really care, and if you keep turning your punch as you work, you can overcome some of that. The anvil was a much more comfortable height to work at. also see where this is starting to bow a little bit along the length, so I think I'll straighten that out. So I just want to take that little bit of a bow out of there to make sure it's straight. It'll behave better. And I don't want as much of this hot, so I'm not going to go right back to the vise. I'll let this part cool down some and just heat this up again. But it's getting very close to what we want. It is just almost perfect. So what I'm going to do for the last heat to guarantee that it actually fits the rivet head, I'm going to put the rivet in a monkey tool, and I'm going to use that to establish my final shape of the inside of the rivet header. Now, the rivets are soft. They won't put up with much pounding. You can't do the whole thing like this unless you want to go through a few dozen rivets. But for this final little shaping, and then the monkey tool helps flat the top of this. And of course, if you're making your own rivets, it is not as important to make it match an exact rivet head size. But if you can, you might as well. That should be all we need to do. As far as the working end goes, now, there are certainly other ways of approaching this. Like I said, you could drill it first and get it almost right to size, then go to the ball tool. You can drill it and then finish it with some other machine tool that creates the right size, whether you'd have to make a shop-made tool to get it exact, or whether those are available as ball-end mills, or whatever it is you might want to use. And again, if you don't need an exact size rivet head, you're making your own rivets, so you're going to create your own heads right from the start, you can use whatever tool you have available that creates something close to the right size. One option for forging them is to use ball bearings. You can make the ball punch by welding a ball bearing to the end of a shaft, although when you get to the smaller ball bearings, it gets a little problematic. Another thing you do is just take a piece of plate, drill a hole smaller than the ball bearing, set the ball bearing on one side, plug weld it from the back, and then you could set that on your anvil and drive the tool down onto it as you create the depression. Lots of options, lots of different ways to approach something like this. Use whatever technology and equipment you have and you're comfortable with. But being able to make the ball punch, which you can use for other projects, and then being able to make the rivet header using that ball punch is something that should be within the grasp of most small blacksmith shops. You don't need a drill press, you don't need a lathe, you don't need a milling machine, you don't need an arc welder. Forge, hammer, anvil, vise, and a little bit of knowledge on heat treating is really all you need. I'm going to go ahead and call this a good video for today. In the next video, we will make a bottom riveting tool that will match this. And then in a third video, we'll do the heat treat on both of the tools. So that'll be a fairly short video, but since I want to cool these tools as slowly as possible, I probably won't get to the heat treat today. And this allows me to go ahead and get this video edited and published and available for you folks out there to watch. So if you enjoyed the video, give it a thumbs up. If you haven't done so already, I would love it if you hit that subscribe button. Feel free to stick around, watch a few of the other videos, share the videos with your friends if you'd like. But then make time in your day to get out to your shop, make something, but stay safe, wear your safety glasses. We'll see you for the next one.